Hello students. So today we will be starting with the lesson Introduction to Three-Dimensional Geometry. Okay, so three-dimensional means all this while we were working in two-dimensional geometry. So now one more axis is added. Okay, so if you have two axes, then there is one more axis. Okay, so x, y and z. This is the origin. Okay, this is your negative x-axis, x dash. This is your negative y-axis and this is your negative z-axis. Okay. So these lines are mutually perpendicular to each other. They constitute the rectangular coordinate system. Okay. Now the planes, this is your origin, right? So the planes x, o, y. Okay. This plane, then y, o, z, then z, o, x are called this is your xy plane, this is your yz plane, and this is your xz plane, okay, or zx plane are the three coordinate planes. Now this planes, they divide this part, okay, into 8 parts. There are 8 regions, okay, and these are called octants. Okay. So if you consider one plane, say XOY. Okay, so one of the octant is XOYZ. Okay, okay, this is the first octant. So there are 8 regions which are called the octants, and you have the sign for the point lying in these octants. Okay, so how do you write a point which lies in a this 3 dimension? Suppose there is a point P. Okay, then the coordinates of P are x, y, and z. Now, according to octant, that is in which octant it falls, the sign of the x, y, z is determined. Okay, so let's write turns and coordinates. Okay, so in the horizontal plane it is octants, and in the vertical thing we are given the signs 4, 5, 6, 7, 8. So how to remember this? First thing, start with first coordinate, that is x. In the first octant it is positive. Okay. Then we have two negatives. Then again two positives and two negatives and plus. Okay. So you can remember this like this. First and last it is positive. In between we have two negatives, two positives and two negatives. Okay. For the y, it is plus plus minus minus plus plus minus minus. Okay. Then for z, it is 4 plus and 4 minus. Okay. So for the first coordinate, it is plus plus. Okay, in the starting and ending. Then in between 2 minus 2 plus 2 minus. For y, start with plus 2 plus 2 minus 2 plus 2 minus. For the z, 4 plus 4 minus. Okay, easy to remember. Let's see some examples. Okay, let's see. We have to write the octants. So the points are given. Okay, so x, y, z. I'll write it here. First plus, minus, minus, plus, plus, minus, minus, plus. Okay, for y, plus, 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 minus, minus. For z, 4 plus are there and 4 minus. Okay, all positive x, y, z. That is first octant. For two-dimensional, we have the quadrants, right? First, second, third, and fourth. Like that, for three dimensions, we have the octants. Fourth, then plus, minus, minus, last, fifth one. And all three are negative. Seventh, first negative, then positive, second, then two negative, last positive, third. Okay. Next is distance between the 2 points in a 3 dimension. So in 3 dimension, suppose we have 2 points P, x1, y1, z1, and Q, x2, y2, z2. Okay. So distance x2 minus x1 the whole square plus y2 minus y1 the whole square z1 the whole square. Okay, so this is the distance between the 2 points in a 3 dimension. Okay. Then we have a section formula also in 3 dimension. That is, if the P and Q line is divided into 2 parts internally with the ratio of m is to n, okay, then the section formula is given by mx2 plus nx1 upon m plus n, my2 plus ny1 on m plus n, and mz2 plus nz1 upon m plus n. Okay, so this is the section formula internally. If the point divides externally, then you have to replace this plus with a negative sign. Okay. Then midpoint, same way like we have in the 2 dimension. Midpoint is given by x1 plus x2 by 2 y1 plus y2 by 2 and z1 plus z2 by 2. Okay. Then there is one more case in which the ratio is k is to 1. Okay. That time you have to substitute m, that is k is to 1, then m is k and n is 1. Okay. Then there is one more formula called a centroid of the triangle. Centroid triangle. So if you have a triangle, say, centroid is a point where the medians, so this is median means this line divides the side into two equal parts. Okay. Where AF, DE and CD are the medians at point O. Meet at point O. Okay. So the centroid is given by the formula. Usually it is denoted by G. Okay. Formula x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3, and z2 plus z1 plus z2 plus z3 divided by 3. Okay. And the coordinates, these are the coordinates of A, B and C. Let's do some examples based on distance formula, okay, from the textbook. So you have to find the distance between the points. Okay, so the distance formula you have to apply x2 minus x1 the whole square, y2 minus y1 the whole square, z2 minus z1 the whole square. 5 square 25, 16, or 20 plus 25, 45. 3 root 5 units. Okay. Next question. So one more thing here is if the distance is from the origin, that is 0, 0, 0 to some point, then the distance becomes x square plus y square plus z square root. Okay. Second question. Show that the points are collinear. Okay. How to show the points are collinear? Using distance formula. Collinear points are the points which lie on the same line. They lie on the same line. Okay. So to prove that they are collinear, we have to first find the distance, that is from P to Q and Q to R. Okay. And then we have to find the distance from P to R. and show that PQ plus QR is equal to PR. Okay. So first we find PQ. Root 40. Then QR root 56. This you can reduce. 7 8 8 you can write 4 into 2. So root 2 you can take outside. So this is 14 root 2. Oh, sorry. 2 root 14. Okay, last you have to find PR distance. Eighty-one plus 126. Okay, reduce it. This is 3 root 14. Okay, so if you add PQ plus QR, you will get PR. So the points are collinear. Next question. These are the 3 vertices given. You have to check whether these are the vertices of right angle triangle or not. So how to check whether these are the vertices of right angle triangle or not? So by using Pythagoras. That is, we need the distances AB, BC and AC. Then you have to show that AC square equal to AB square plus BC square. Okay. It can be AB can be hypotenuse also. Okay. So first you find out the distances. AB 7 square, 14 square, 30 minus 9, 21 square. 686. Okay. So we need AB square. So I'll take this root that side. So it becomes AB square is 686. Okay. Let's find out BC. Calculate directly. 25 minus 10 square minus 41 minus 20. So this you have to add 61, I minus 30, 25. Four, five, seven, one. Let's see. This is square. 22 square. 47 square. Minus okay. Check for AB square plus BC square is equal to AC square. Five two five seven, and this is 2709. Okay, so this is not a right angle triangle. Next question. Find the equation of set of points P such that PA square plus PB square is equal to 2K square, where A and B are given. Okay. So we have to find the equation of set of points P. First find out PA square. Let P be the point, say x, y, z. X minus 3 square. PA square, so no root is required. Okay. This two you have to add and see whether you get 2K square. What we have to find? We have to just find the equation. So you have to equate to the 2K square. Okay. So adding this two, I'll directly write this addition equal to 2K square. Okay, so you have to solve this. Solve x square 6x 9 2x square 2y square 2z square minus 6x plus 2x is minus 4x minus 8y minus 6x minus 14y minus 10z plus 14 plus 4. Okay, 9 plus 16 is 25 plus 25, 50, 50 plus 1, 51, 51 plus 9, 60, 60 plus 49, 109 equal to 4k square. Okay.